Imagine, imagine you park your car in the garage and you turn the engine off, take the keys out, lock the door, and you come back like 4 days later, and not only is the car running, but the engine is like red hot and the gas tank is completely full.
Right. Yeah.
You wouldn't just be confused by that. You'd be fundamentally terrified because what you're looking at completely breaks the basic rules of cause and effect.
Oh, absolutely. You'd have to assume the fundamental laws of thermodynamics just stopped applying to your garage.
Right.
Because the energy has to be coming from somewhere, and if it's not coming from the gas tank, then reality as you understand it is just breaking.
Yeah. And today, we're going to see how exactly that kind of terrifying, reality-breaking anomaly gave birth to the modern world. So, welcome to our deep dive into the true story of Pierre and Marie Curie and the discovery of radioactivity.
It's quite a story.
It really is. And our guide for this journey is this incredibly detailed book called Light from the Atom by the author Boris Kriger.
Yeah, and our focus today with this deep dive is to really strip away the historical varnish, so to speak.
Right, the myths.
Exactly. We have these persistent kind of romanticized legends of the Curies, right? The glowing test tubes, the solitary genius in a freezing shed.
Right.
But the real story that Boris Kriger presents in his book is so much more profound. We're going to examine how they took a phenomenon that was completely invisible, like completely inexplicable, and found a way to drag it into the physical world as hard numbers. And by doing that, they basically dismantled our entire understanding of what matter actually is.
Well, I want to start by pushing back a bit on the timeline of that discovery, because the popular narrative always starts with a different scientist, Henri Becquerel, in this supposedly lucky accident.
Right, the cloudy days in Paris.
Exactly. The story goes that in 1896, Becquerel was trying to prove sunlight caused uranium to emit X-rays. But it was a cloudy week, so he just tosses his photographic plates and the uranium into a dark drawer.
Yeah.
And days later, he develops the plates anyway and finds this blazing image. So the textbook version treats this like a happy accident caused by bad weather.
Yeah, the textbook version is a massive oversimplification, which Boris Kriger actually thoroughly debunks in Light from the Atom.
Oh, really?
Yeah. Becquerel was a highly methodical physicist. He didn't just forget about the plates or, develop them on a whim. He was running a very strict control experiment.
Oh, boy.
So he intentionally placed them in the dark drawer, fully expecting the developed plates to be completely blank. That blank result was supposed to be the definitive proof for his hypothesis, which was that sunlight was the required fuel for the uranium's glow.
Okay, wait, so the dark drawer wasn't just a storage space, it was the actual test environment.
Exactly.
And he developed the plates specifically to prove that without the sun, the whole system is dead.
Oh, correct. So when he pulled out those plates and saw a stark, high-contrast image, he wasn't celebrating a lucky guess. He was staring at the complete destruction of his own hypothesis. The radiation was, it was continuing in complete darkness with absolutely no energy input, seemingly forever.
That is your car running in the closed garage with no gas.
That's exactly what it is.
Which, that should have set the scientific world on fire? But it didn't, right? The community largely ignored it at first.
They did. They largely met it with a collective shrug.
Why?
Well, the primary reason was the limitation of Becquerel's measuring tool, the photographic plate itself. You see, a photograph is a qualitative result. It gives you a smudge on a piece of glass.
Right.
You might look at two plates and say, well, this smudge looks a bit darker than that one. But you cannot extract a hard mathematical ratio.
Gotcha.
And without a precise number, you can't build an equation. And without an equation, you can't truly interrogate the physics of what's happening.
So the phenomena was basically locked behind a blurry image. And to actually understand this invisible force, someone had to figure out how to put a hard number on it. And I guess this is where Marie Curie steps in, abandoning the photographic plates entirely for a piece of equipment that seems, well, almost bizarre for this kind of work.
It was very unusual. She adopted this incredibly obscure, delicate instrument that had been invented 16 years prior by Pierre Curie and his brother Jacques.
Okay.
It was called a piezoelectric quartz balance. And they had built it for entirely different experiments, but Marie realized its unique potential for capturing the invisible.
I really want to unpack the mechanics of this because the idea of, weighing an invisible ray sounds a bit like magic. How does a quartz balance actually capture radiation?
Well, it comes down to piezoelectricity.
Yeah.
Pierre and Jacques had discovered that if you take a precise slice of a specific crystal, like quartz, and you compress it in a vise, the physical pressure forces electrical charges to pool on the surface of the crystal.
Yep.
And crucially, the amount of electric charge generated is mathematically proportional to the amount of physical weight you apply to the quartz.
Oh, I see. Okay, so physical weight translates into an electrical charge.
Yes.
But how does that bridge the gap to, measuring a rock of uranium?
That's because of what the uranium is doing to the air around it. The radiation from the uranium ionizes the air. It acts like microscopic bowling balls knocking electrons off the air molecules.
Oh, wow.
Yeah, and this creates an unimaginably tiny electrical current in the air, what we call picoamperes. To give you a sense of scale, a standard light bulb might use half an ampere. Marie was dealing with a trillionth of an ampere.
A trillionth. Okay, so she has this incredibly weak current coming off the uranium, pushing a delicate needle on a scale in one direction.
Yes, and here's the absolute genius of her setup. She creates what's called a null instrument. To measure the exact strength of that uranium current, she uses the quartz. She physically hangs little metallic weights onto a tray attached to the quartz crystal. The quartz compresses, generating its own electrical charge, which she routes to push the needle in the exact opposite direction of the uranium's current.
Oh, she's playing electrical tug-of-war.
Exactly.
She keeps adding or removing physical weight to the quartz until the needle sits perfectly at zero.
Yes, and she timed this with a stopwatch. By knowing exactly how many grams of physical weight she had to hang on the balance to keep the needle at zero over a specific number of seconds, she produced a hard, irrefutable number for the radiation.
Wow.
She took an invisible, ghostly ray and translated it into physical grams on a scale.
That completely redefines the playing field. I mean, she's not looking at blurry smudges anymore.
No.
She has an absolute measurement. And she's doing this incredibly delicate balancing act, which requires absolute silence and intense physical concentration in a damp, unheated storeroom where, the temperature would drop to 6 degrees Celsius.
Yeah, that's around 43 degrees Fahrenheit. Her fingers would literally be freezing as she manipulated these tiny weights.
That's intense.
It really was. But this absolute measurement led to what Boris Kriger identifies as the foundational turning point in nuclear physics, which is Marie Curie's proportionality law. Because she had a reliable number, she began testing the uranium under every conceivable condition.
She basically tortured the samples.
She really did. She tested the uranium wet, dry, heated to high temperatures, cooled to freezing. She tested it in bright light, in total darkness. She combined it with other elements to form different chemical compounds. So she's testing uranium sulfates, uranium oxides, pure uranium metal.
And the needle never deviated.
Never. The only variable that changed the amount of weight she had to place on the balance was the raw quantity of uranium present in the sample. The temperature, the lighting, and most importantly, the chemical state of the uranium had absolutely zero effect on the radiation it produced.
Okay, let me stop right there, because the chemical state not mattering is a massive clue.
It's huge.
Because if I burn a piece of wood, its chemical state changes, and it releases heat. But chemical bonds only involve the outermost layer of an atom, the valence electrons, the outer shell.
The outer wrapper of the atom, yes.
Right. So if she is completely altering the chemical structure, changing the wrapper, and the radiation doesn't change by even a fraction of a picoampere, then the radiation cannot be a chemical reaction.
No, it can't.
It has to be coming from deeper inside.
It has to be coming from the nucleus, though, they didn't have that word yet.
Yeah.
You really have to put yourself in the mindset of a 19th-century scientist to understand how explosive this was.
Right.
Because the very word atom is derived from Greek, meaning uncuttable or indivisible.
Right.
The entire bedrock of chemistry at the time rested on the assumption that atoms were the smallest permanent solid blocks of reality. They had no internal parts.
And Marie Curie, based entirely on the unmoving needle of her balance, declared that the indivisible atom actually had a complex interior.
Yes.
And that interior was actively leaking energy.
She proved the indestructible building block of the universe was falling apart. That fundamentally rewrites reality.
It really does. And once they know they have a reliable tool to measure this atomic property, they start pointing it at everything, which leads them straight into a mathematical trap hidden in a pile of dirt.
Yes. So they began testing natural, unrefined minerals from different mines. And one of these was pitchblende, which is a dense black uranium ore from Bohemia.
Oh, yeah.
Now, because Marie had her proportionality law, She could calculate exactly how much radiation the pitch blende should emit just by knowing the percentage of uranium inside it.
Right.
But when she placed the raw pitch blende in her apparatus, the measurement was roughly 4 times higher than it should have been.
It's like ordering a standard cup of black coffee, but you take one sip and you get a caffeine jolt equal to 4 double espresso.
Yeah, exactly.
You don't need a chemical analysis to know the barista slipped a secret ingredient into the cup. There has to be something else in the rock.
And that secret ingredient had to be a completely unknown, incredibly radioactive element. But Boris Kriger meticulously lays out the brutal mathematical problem the Curies were suddenly facing here.
Okay, what was it?
The excess radiation they were measuring was a product of 2 completely unknown variables.
Right.
The specific radioactivity of the mystery element and the actual quantity of it hiding in the rock.
Oh, because it could be a large amount of a mildly radioactive element or a microscopic speck of something unspeakably powerful.
Right. So when they began the extraction process, they assumed this new element might constitute roughly 1% of the pitch blende.
Okay.
That assumption was off by 5 orders of magnitude. The new element turned out to be 1 part in 3 million of the ore.
1 part in 3 million.
Yeah.
That's not finding a needle in a haystack. That's the equivalent of searching for one specific misspelled word hidden inside a library of 100 thick encyclopedias.
And to find that misspelled word, they had to chemically process a full ton of dirt. This meant physically hauling sacks of ore, dissolving it in giant vats of acid, and Marie literally stirring boiling cauldrons with an iron rod almost as tall as she was.
Good grief.
Yeah. It took 4 years of this back-breaking industrial labor in that same freezing shed just to isolate 1/10 of a gram of the new element.
And actually, before they even isolated that tiny fraction of radium, they found a different element in the pitch blende first. Boris Kriger details how, in 1898, they isolated a substance and Marie named it polonium, which was a deeply significant choice.
She named it after her homeland, Poland.
Right, but the geopolitical reality at that time makes this fascinating. Because, Poland didn't actually exist on any map in 1898.
Right.
Boris Kriger points out that the territory had been aggressively partitioned and absorbed by the Russian, Prussian, and Austrian empires. And Marie grew up under occupation where teaching Polish history or language was strictly illegal.
So naming the element polonium was a masterful stroke of scientific defiance.
It really was.
The periodic table is a permanent, universal ledger. You can erase a nation's borders with an army, but no emperor on Earth has the jurisdiction to remove element 84 from the fundamental fabric of the universe.
It basically locked the existence of her country into the laws of physics.
Yeah.
But while polonium was a profound gesture, it decayed very rapidly. It was their subsequent discovery, radium, that truly upended the world. Because once they finally concentrated that ton of dirt down to a fraction of a gram of pure radium, its physical properties were amplified to a terrifying degree, especially its temperature.
Oh, the heat was unbelievable. In 1903, Pierre Curie and an assistant finally measured the ambient heat coming off a concentrated radium salt.
Okay.
And they discovered that 1 single gram of radium emits roughly 100 calories of heat every single hour.
Wow.
And it does this continuously, indefinitely, without cooling down, without changing its physical shape, and without consuming any external fuel.
We are back to the car, in the garage. It looks exactly like a perpetual motion machine. It appears to be creating energy out of absolutely nothing, which violates the core dogma of 19th-century physics, the conservation of energy.
The scientific establishment was so shaken by this that Lord Kelvin, who was arguably the most prominent physicist alive at the time, publicly refused to accept it.
Really?
Yeah. He argued in the press that radium couldn't possibly be generating its own heat. He proposed that radium was simply acting as an antenna, absorbing some unknown invisible space energy and re-radiating it as heat.
He was willing to invent magical space rays just to protect the laws of thermodynamics.
Exactly.
Because the alternative, that the tiny microscopic atom contained a massive hidden reservoir of internal energy, was just too terrifying to contemplate. And Pierre Curie didn't just measure the temperature. He wanted to see what this unprecedented energy did to biology.
Yes. Pierre essentially birthed the field of radiobiology on his own body.
Unbelievable.
In 1901, he strapped a glass tube containing a radium sample directly to his forearm and left it there for 10 straight hours.
10 hours.
10 hours. And over the next 52 days, he meticulously documented the pathology. The initial redness, the severe blistering, the deep, agonizing ulceration of the tissue,
Oh, man.
and the incredibly slow, painful healing process that left a permanent gray scar.
So he proved, beyond any doubt, that radium radiation systematically destroys living human flesh.
Yes.
Yet despite publishing this gruesome proof, the broader culture reacted the exact opposite way. We entered the radium craze.
The commercial response was entirely unhinged from the science. Boris Kriger explains how the medical and commercial communities adopted this twisted logic known as hormesis.
Right.
The assumption was, well, if a massive dose of radium destroys tissue, then a tiny microscopic dose must gently stimulate and invigorate the cells.
Which is a catastrophic misunderstanding of how cellular damage works.
Absolutely. It led to radium being marketed as a miracle cure-all. It was compounded into face creams to brighten skin, mixed into toothpaste for glowing smiles, and most dangerously dissolved into drinking water as a health tonic.
The specifics are just horrifying. You look at the case of Eben Byers, who was a prominent industrialist and amateur golf champion.
Right.
He believed so deeply in the invigorating properties of radium that he drank over 1,400 bottles of a popular radium-infused water called Radithor.
Oh, so tragic.
The radiation literally dissolved his skeleton from the inside. His jaw collapsed and had to be surgically removed, and he ultimately had to be buried in a lead-lined coffin to prevent contaminating the soil.
And the Byers case was highly publicized because of his wealth, but an even larger systemic tragedy unfolded with the so-called radium girls.
Right, the factory workers.
Yeah, these were working-class women employed in factories to paint watch dials with luminous radium-laced paint for the military and the public, and to maintain a razor-sharp point on their paintbrushes, factory management instructed the women to use their lips to shape the bristles.
They were swallowing microscopic amounts of radium day after day.
Exactly. And the biological mechanism here is what makes it so insidious. Radium is an alkaline earth metal sitting right below calcium on the periodic table.
Which means the human body cannot tell the difference between the two.
Correct. When these women ingested the radium, their digestive systems treated it exactly like dietary calcium, routing it straight into their skeletal system.
Oh.
The radium became permanently locked inside their bones. But radium isn't inert. It's constantly firing off alpha particles. And inside the body, an alpha particle acts like a microscopic cannonball. For years, these embedded atoms simply shredded the women's bone marrow and cellular DNA from the inside out.
Leading to horrific conditions like jaw necrosis, severe anemias, and aggressive bone sarcomas a decade later. But the companies that employed them fiercely denied any responsibility.
They denied it because it broke the existing legal and medical paradigms.
What do you mean?
Well, the legacy of the radium girls is that their suffering forced the creation of modern workplace safety and radiation protection standards. Before this, an occupational injury was something immediate, like a machine crushing a hand or a chemical burning the eyes.
Oh, I see.
The medical system had no framework for a substance you couldn't see or feel, ingested in microscopic quantities, causing a fatal cancer 15 years down the line. It introduced the modern concept of an occupational disease with a long latency period.
The delay between exposure and consequence is terrifying. And this concept of latency perfectly contextualizes the most famous and perhaps most misunderstood story about Marie Curie herself.
You're talking about the narrative of her death.
Right. It is practically general knowledge at this point that Marie Curie was killed by the radium she spent her life isolating. Everyone cites the fact that her original laboratory notebooks are so deeply radioactive that even today they are kept in lead-lined boxes at the National Library in France. And researchers have to wear protective gear just to view them. It's like the ultimate poetic tragedy, right? The genius martyred by her own brilliant discovery.
It is a beautifully tragic narrative, but Boris Kriger drops a significant revelation in his book that completely dismantles it.
Oh, really?
Yeah. In 1995, the French government decided to inter the remains of Pierre and Marie Curie in the Pantheon in Paris, which is the highest national honor. But because of the lingering fears about her radioactivity, radiation protection officials carefully tested Marie's bones during the exhumation.
Okay, and what did the sensors show?
The results were startling. Her skeletal radium burden was incredibly low. It was nowhere near the threshold required to have caused the severe aplastic anemia, the complete failure of her bone marrow, that ultimately killed her in 1934.
Wait, if the radium inside her bones wasn't high enough to be fatal, how do we explain the notebooks? They are objectively radioactive.
This is where we have to distinguish between internal ingestion and surface contamination. The notebooks are highly contaminated because she was working in that shed, handling radium ores and touching the paper with unwashed, dust-covered hands. The books absorbed the physical dust.
Right.
But Marie Curie herself had incredibly strict laboratory hygiene for the era. She didn't lick paintbrushes. She didn't ingest or inhale enough of the raw element to destroy her internal marrow.
So the entire martyr to radium myth is factually incorrect.
It is.
But she definitively died of a radiation-induced illness.
Mm.
If it wasn't the radium in the shed, where did she receive the fatal dose?
The answer lies in her actions during the First World War, and it completely shifts how we should view her legacy.
Okay.
When the war broke out, Marie Curie saw that military surgeons were operating on soldiers with shrapnel embedded in their bodies, essentially probing blindly into wounds because they had no imaging equipment at the front lines. She realized X-ray technology could save thousands of lives, but the machines were confined to city hospitals. So she invented the little Curies.
She mobilized the technology.
Exactly. She retrofitted civilian cars, installing X-ray machines in the back and hooking them up to dynamos driven by the car's engine.
Wow.
And she personally drove these mobile units to the bloody front lines of the war. But these were early, primitive X-ray tubes with absolutely no lead shielding. For 4 years, she operated these machines continuously. She would personally, physically hold bleeding, terrified soldiers in place in front of the unshielded beam to get the images the surgeons needed.
Over the course of the war, it's estimated those mobile units treated upwards of 1 million wounded soldiers.
Yeah, she absorbed massive, concentrated, unshielded doses of directed X-ray radiation day after day, year after year.
Oh, man.
That acute, overwhelming exposure is almost certainly what irreversibly damaged her bone marrow, leading to her death decades later.
That is a staggering reframing of history. We cling to this neat, poetic irony of the obsessed scientist killed by her beloved element, but the reality is far more noble. She didn't die because of her obsession with radium. She died because she knowingly sacrificed her own cellular health to ease the suffering of 1 million young men.
It fundamentally elevates her character. And this historical correction leads directly into the overarching philosophical argument Boris Kriger makes in Light from the Atom.
Which is?
We have this assumption that the history of science is a straight, clean line of undeniable progress. But Kriger argues that while our physical measurements might be flawless, our human interpretations, the myths we build, the labels we apply to those numbers, are incredibly fragile and often entirely wrong.
The ontology of science, right? Like, how we define what actually exists is a lot messier than we like to admit.
Immensely messy. Take the period right after the Curies discoveries, between roughly 1898 and 1913. Laboratories all over Europe were suddenly finding new radioactive materials. By 1913, the greatest scientific minds had formally announced the discovery of roughly 40 brand new radioactive elements.
40.
40. They had names like ionium, mesothorium, radiothorium, uranium X. Each one had a completely unique half-life and distinct radioactive behavior.
40 new elements in 15 years. The periodic table only had about 90 slots to begin with. It must have been absolute chaos.
The table literally didn't have room for them. The foundation of chemistry was buckling. And then in 1913, a chemist named Frederick Soddy proposed a radical solution. He analyzed the data and proved that these 40 distinct elements were actually just 10 elements masking themselves in different physical forms.
Oh, he discovered isotopes. The concept that an atom can have the exact same chemical face acting exactly like carbon or uranium in a chemical reaction, but have a completely different internal mass and a different radioactive half-life.
Precisely. Soddy proved that chemical identity and atomic weight were not inextricably locked together. And with that single realization, 30 celebrated chemical elements simply vanished from the scientific record overnight. They never existed.
But this is what makes it so mind-bending. The measurements that created those ghost elements weren't wrong, were they?
That is the genius of Krieger's observation. Not a single number had to be corrected.
Yeah.
Every half-life, every decay curve, every meticulous measurement recorded in laboratory ledgers across the world was perfectly accurate. Nature was giving them the correct numbers. But because the scientists were operating under the century-old dogma that a different half-life must mean a different element, they hallucinated 30 new substances.
That's incredible.
The data was robust. The human explanation was an illusion.
We measure reality perfectly, but our preconceived biases blind us to what the numbers are actually saying. And I want to leave our listeners with one final story from the source material that illustrates this perfectly, involving the next generation of the Curie family.
Ah, the Joliot-Curie anomaly. It's a phenomenal example of paradigm blindness.
In 1932, Pierre and Marie's daughter, Irene Joliot-Curie, and her husband, Frederick, were conducting experiments in Paris, and they had inherited the best equipment and the deepest institutional knowledge of radiation in the world.
Right.
Over the span of a single year, they produced pristine, mathematically flawless data, capturing two completely unknown subatomic phenomena.
Their experimental setups were exquisite. The measurements were undeniable.
But when it came time to publish their conclusions, they completely misidentified both discoveries.
Yeah.
They were looking directly at the data for the neutron, but because they couldn't imagine a heavy particle without an electrical charge, they labeled it a weird proton effect.
Yeah.
And then a few months later, they literally photographed the track of a positron. But because they firmly believed all electrons were negative, they published a paper claiming it was just an electron traveling backward toward the source.
They had the physical proof in their hands, but their minds couldn't accept what the universe was showing them. Within months, two other scientists, James Chadwick and Carl Anderson, looked at the exact same data, broke free of the old paradigms, gave the particles their correct names, and were immediately awarded 2 Nobel Prizes.
It brings us right back to that car running in the garage. Nature provides us with a dashboard. It gives us the dials, the needles, and the perfect numbers. But the universe doesn't provide the instruction manual.
No, it doesn't.
It is entirely up to us to strip away our assumptions, exercise our judgment, and figure out what the engine is actually doing. The numbers never lie, but our imaginations can lead us completely astray. It is a profound reminder to deeply question the labels we put on the facts we hold so dear. And, well, that's something to mull over the next time you think you have reality all figured out.